Hi folks, welcome back. This is a video about subnetting. I tried to learn subnetting before and I thought I understood what CIDR is, but when you say one network or two networks or three, I didn't really understand what it meant. So I went through this page as well as links to all of these. So this is a Class A subnetting. There are pages for Class B and Class C as well. So yeah, I'm gonna go through all of them with you right here. Let's find out what a subnet is. Okay. Let's say we got a Class A network 10.0.0.0 with default subnet mask 255.0.0.0. Do you know why this is a Class A? Well, default, I'll call it default Class A network because the net mask has this format, right? That is why. You'll see it later on. Well, immediately after this, actually, how a default Class A network will become multiple networks. Okay. You see what I mean? Says the network address is this. First usable address is 10.0.0.1. Second is 10.0.0.2 and so on up to 10.255.255.254, and broadcast address is the last one, 10.255.255.255. So you can see in this diagram, we start from the network address, then we have first, second, and third, and so on, and then we got the last address and the broadcast address. So for each network, you must have a network address and a broadcast address. Network address is the first IP in the network. Broadcast address is the last IP in the network, and you cannot use these two in a device inside the network. The usable IP addresses come after the network address and before the broadcast address. And it says here it's on subnetted Class A network. Okay, that means you'll see it later, but it just means there's only one network. Okay. So I'll say it again. This is a on subnetted Class A network with subnet mask 255.0.0.0, and that means there is only one network or one subnet. Okay, as you can see in this diagram. So yeah, so here you set the okay. All right, so this is a network address, and this is in a binary, and I want to stress that for a default Class A network, the network address is divided into two parts. First, well, yes, it says first octet is used to represent the network. So we are saying this is the first one, okay? This is a network portion. And this is the host portion, okay? And to get the subnet mask, you just change the first octet to all ones and change all the host portion to 0. Okay. Let's go through one bit, well, class A 1-bit subnetting. Okay. So what's changed is we are using a class A network. So this is the network bit by default. To do 1-bit subnetting, we borrow from the host portion 1 digit, okay, and we reserve this digit for separate networks, okay. So here the orange portion is the network. Now we borrowed this 1 bit from the host. The rest is the host portion, okay. The network address doesn't change, okay, but the subnet mask change, okay. 128 is just a decimal value of this binary, okay. So the network address has not changed, but the subnet mask changed to reflect how we have borrowed 1 bit from the host portion to use as separate networks, okay. So here well, to be more succinct, this is a network address of the first subnet, okay. Why do we have two subnets? Because here we borrowed 1 digit from the host to act as a network placeholder, right? So this 1 digit can have two values, either 0 or 1. That's why we have two subnets now, or two networks. And I said the network address of the first subnet is 10.0.0.0, as we have here. Well, here. And then the first IP address, well, is 10.0.0.1. The last IP address is, as we can see here, we have borrowed this bit to represent all the subnets. All right. So the very first usable IP starts from here. We remember we reserved this portion for networks. The last IP is all ones except for the first digit, but of course we reserve this one, so this is not counted. The broadcast address is the very last IP possible. Again, we don't touch this bit because this we borrowed from the host to use as marker for each subnet, as I said. So the rest of the host portion are all ones. That's the broadcast address. And this is the first subnet. The second subnet, we turn this bit into 1. Okay, why do we have two separate, two possible subnets? Because this bit can be 0 or 1. Okay, the same as before. The network address, excluding this bit, all has to be 0. That's the network address. The first one, we start from here. The last one, excluding this bit, sorry, all others are 1s except for the first digit. And as we said, the broadcast address of the second subnet is, excluding this bit, all others are 1s. Okay, well here this bit is 1 as well, but anyway, you can see more clearly using this diagram. Okay, so we are dividing this whole all the possible IP addresses. We're gonna divide them into separate subnets. Okay, I said that 10.0.0.0 is the network address of the first subnet, as we can see here, and then we assign IP address for the devices inside the first subnet, and we reach the broadcast address, and then we begin the network address of the second subnet, and then we assign IP address for the device, all the devices in the subnet 2, and then we reach the broadcast address of the second subnet. Okay, here we go to 2-bit subnetting. This time we are borrowing 2 digits from the host portion. So how many possible subnets are there? Well, it's 2 times 2, so there are 4 of them, right? So the 2-bit subnetting results in 4 subnets, or 4 networks. Okay, let's have a look here. So here we're reserving these 2 for the subnets, alright? And we start with the first subnet. As I said, all of them excluding these 2 bits are 0. And then we start assigning IPs to the devices, and then the broadcast address, except for these 2 bits which we borrowed, all others are 1. That is the broadcast address of the first subnet, and then second, third, and fourth, and so on. Okay, so this is the diagram. Well, let me go through this one. It says the this network 10.0.0.0 is divided into 4 subnets, as we've seen. It says each subnet has 4.1 million total addresses. How do we get that? Well, each subnet has this much to assign, right? So how many bits are there? There's 16 plus 16 plus 6, isn't it? Is it? So 22. Let's try it. So can you see it's saying 4.19 million? 4.19 million. Okay. And from that, the usable addresses, IP addresses are this minus 2. Why? Because the first one is the network address, the last one is the broadcast address. Okay. Okay. Let's do. Well, I was gonna skip this part, but I told myself, why not be more thorough? So I did. Okay. Yeah, I'll try to be very thorough. Now the Class A 3-bit subnetting.
You can guess what it means, right? What does it mean by Class A 3-bit subnetting? Okay. Again, we start with the subnet mask. All first octet all being ones, and all other octets being 0. And then we assign from the host portion, this time 3 bits. Okay? And I think the network address is still the same. This is used to identify the network. Well, anyway, or set of networks in this case. Or set of networks, I mean. Okay, and the subnet mask has changed to, well, 224 is just this in decimals, okay? It's the same as before. Let me just show you this diagram. So we divided into 8 different subnets. Why is it 8? Good question. 2 to the power of 3 is 8. So we got 8 different networks. Okay? So that's what it is. Same here. So network address, first IP address, last, and then broadcast, network address, first IP up to the last, and then broadcast, and so on. Goes on. So in effect we have 8 different networks. Okay. So here it says the network 10.0.0.0 is divided into 8 subnets. Each subnet has around 2 million IP addresses. Okay, so how do we get that? Well, remember we have borrowed 3 bits. So we're left with this. Okay, so we got one less bit for the host. Okay, so what's that? It's 2.09 million. Is it correct? Yeah, 2.09 million. And from that, the usable ones is -2. And you know why? It's because those 2 are reserved. Okay, so remember the first one is the network address and last is the broadcast address, and that is true for each subnet. Okay, each subnet has 2 IP addresses reserved. First one is the network address, the last is the broadcast address for each subnet, not just one here and another here, but each subnet. So you should know that. Okay, let's go to part 2. Okay, part 2 is just 4-bit. Okay, this time Class A 4-bit subnetting. Okay, can you guess how many subnets or networks are possible if you borrow 4 bits? Well, it's very simple. 2 to the power of 4, 16. Okay, so we got 16 possible networks under this configuration. Okay, so as I said, the subnet mask gives away what is happening. So 240 is the decimal for this binary. Okay, so you can, if you know the subnet mask, you know exactly what is going on. This subnet mask, given that it is a class A, it tells you how many bits it has borrowed from the host. Okay, for sake of designating 16 subnets in this case. This is the same. Okay, first
Subnet got network address and usable IPs and broadcast address. The second one also has a network address, usable IPs and broadcast address, and so on until the 16th subnet. Okay. Well, can you calculate how many possible subnets? Oh, sorry, how many possible hosts each subnet has? The total hosts possible? Well, as you can guess, it's one less bit. Oh, sorry, that's not it. Oops, sorry, I'll just do it here. So, yep, so we got these bits for the host. So 884. Okay, so 884. It says 1.48 million. Yep, 1.04 million. 1.04 million. Okay, so that's how you calculate. This is the table of all the possible configurations, starting from 0 subnet bits. So do you know why the default class A network only has one subnet? Because we haven't allocated a single bit for the subnet. So if you don't borrow any bits, then there's only one subnet, or in other words, only one network. So if you have a default class A subnet mask as here, it means there's only one network. Okay, now you know. And as you borrow more bits for the network, the subnet mask changes to reflect that, and the total subnet increases, and of course the usable IP decreases. So show you here. Okay, so why do you know why the subnet bits, maximum subnet bits you can borrow is 22? What is that? So that's so we start from here because it's a class A, right? The maximum we can borrow, I guess, is 24 bits, 8 times 3. Okay, but what? Sorry. So why 8 times 3, 24? So here we only borrowed up to here. And why don't I borrow the last remaining 2 digits? Because here the number of possible hosts is 2 to the power of 2, which is 4. Okay, and the usable IPs are 4 minus 2, which is 2. Okay, so this is the number of possible hosts. That's the number of possible usable hosts. So you can see here, this column is usable IP addresses. There's only 2 because it's 4 minus 2. Okay, this is same for any class A, B, or C. Okay, this is a restriction. The same restriction applies because of the number of hosts. Okay, the number of hosts must be at least 4 because you gotta subtract 2 for the network and broadcast addresses. Okay,
what happens if you do this? The number of hosts is just 2. Okay, 2 to the power of 1. So look at this. Usable host is 2 minus 2, which is 0. That's why it's not in the list. Okay. Okay. Let's do class B. Class B. Let's start. Wait for it to load. Okay. So this is, we start from the scratch for each class. So this is with class B, but this is unsubnetted class B network. So can you guess this default subnet mask? Should be 255.255.0.0, right? And from this third octet, we're gonna borrow bits to assign to a different network. Okay, the same thing, just default subnet mask changed. Can you remember what the default subnet mask is for the class A? It was 255.0.0.0. Okay, that's the difference. Okay, so if it's unsubnetted, as we see here, you start from here, and then there's network address. All these are usable IPs, and then the last IP usable address, and then the end with broadcast address. Okay. So can you guess how many hosts are possible with unsubnetted class B network? The host part is the third and fourth octet, right? So that's 16 digits, right? So it should be well, am I doing it wrong? Yeah, it's wrong. What am I doing? Oh, sorry. Well, yeah, I'm right. Sorry. I was wondering, why is it less? Why is this one bigger than this? Because this calculation was based on class A, and this is class B. Okay, so I'll say it again. Given this subnet mask, how many hosts are possible for the unsubnetted class B network? There's, if you see here, under the subnet mask, it shows you how many bits are for hosts, and these are 16 bits, right? So yes, 65,000 hosts possible by default. Okay, if you have only one network. Okay, so class B network has significantly less number of networks or hosts possible, because there's less bits to work with, and class C should be even less. Okay, very good. Let's go through class B 1-bit subnetting tutorial. Can you guess what will happen? You will borrow one bit from here for this network portion. Okay, from the host portion. So how many subnets are possible? 2, right? Same thing as class A. So the 172.16.00, that's the network address. We have reserved this bit over here for the network. Yep. And if you fill in all the other bits as 1, becomes a broadcast address. And if you turn the borrowed bits to 1, then that designates second subnet.
So it starts with network address, usable IPs, and turn everything to 1, then it becomes the broadcast address. So if you look at this diagram here, which is very useful, you can see that it starts with the network address for the first subnet, then usable IPs up to the last usable IP, and then the broadcast address. Then begins the network address for the second subnet, and then usable IPs, and then the broadcast address for the subnet 2. It's very similar to class A, just less number of bits to work with. Now 2-bit subnetting for class B. Now we have borrowed 2 bits from the host. So how many subnets? Well, how many networks? 2 to the power of 2, so 4. Same thing over here, okay? Where's the diagram? Here you go. So we divided the whole thing into 4 equal size subnets, and each subnet has the network address and the broadcast address, okay? As with the class A. Now the 3-bit subnet for class B. Now we borrowed from the host portion 3 bits. So how many subnets are there? 2 to the power of 3, 8. Okay? Come on, picture. But the picture don't want to load. Oh, there you go. So now there's 8 different equal size subnets. Each of them has network address and the broadcast address, and also, of course, the usable IPs. Okay, here I forgot to go through this portion. How many bits? 3-bit subnetting. So how many how many total IP addresses for each subnet? So well, we've got this portion reserved for host. How many bits? 8 plus 5, right? 8 plus 5. 8,000 possible IP addresses. If you minus 2, that becomes this much usable IP addresses. Why? Because each subnet has network address and broadcast address reserved. You cannot use network and broadcast address for the devices in each network. That's good. You understand this? Now let's go to class B, part 2. Okay, 4-bit now. Wait for the pictures to load. Okay, so the 4 bits, we borrow 4 bits for the network. So how many networks possible? 2 to the power of 4, 16, right? We got 16 different networks. Okay, so how many hosts possible for each subnet? Look at here. So we got this much for the host portion, right? So 8 plus 4. We got just 4,000 possible IP addresses, okay? And also, of course, the usable ones are minus 2. And this is the table for all the possible configurations. Also here, here, sorry. We borrowed 4 bits, right? So this is a class B, and we borrow some bits from here, right? Well, sorry, it should be. So this is class B. So we can borrow maximum, theoretically, without checking, can borrow 16 bits, but only 14 bits here. Same reason as up here. Okay. Do you want me to go through it? Well, if you borrow a plus 6, which is 14, the usable host, sorry, the total number of hosts are 4 as above, but usable hosts are -2, so it's 2. But if you have only 2 possible hosts, then usable hosts are -2, which is 0. That's why 14 is the maximum bits we can borrow for class B. Okay, excellent. Now same thing for class C. Here we go. Wait for the pictures to load. Okay. Well, CIDR is just a number of the bits assigned to the network portion, okay? Okay. Where's... Sorry, I'm just backtracking here. There should be a diagram for it. What is it? Yeah, there you go. Yeah, we'll get there. Okay, let's this diagram is saying if it's a default class C network. How do we know that? You know it by the subnet mask. 255.255.255.0 is the default class C, and as you can see here, the last octet is 0. That means there's only one network. So these two IP addresses, 192.168.10.100, 192.168.10.200, they belong to the same network, so they can ping each other. Okay, but here this is not a default subnet. Okay, so in this case, this IP and this IP, they belong to a different network, so you can't ping each other directly. It has to go through a router. Okay, that's what it means. Just wanted to mention the port. Let's do 1 bit subnetting class C. Okay. Here, we borrow 1 bit from the last octet. How many subnets? 2, right? So we got 2. Okay, let's go through this. So it's divided into 2 subnets. Each subnet has 128 total possible IP addresses. How do we know that? Well, here, how many host portion? 7 bits, right? So just 2 to the power of 7, right? 128. So there's far less number of hosts per subnet. in class C as compared to class A or class B. So it's more restrictive in the number of networks and also number of hosts per network. So they all have different use cases, I guess. So we know that each subnet has 128 and 126 usable because -2. Okay. Alright, so if you look at here, we got for the first subnet, we got network addresses, usable IPs, and the broadcast address. Second subnet also has a network address, usable IPs, and broadcast address. Okay. Now, class C 2-bit subnetting. Now we borrow 2 bits from the host portion. Okay. So how many subnets? 4. Okay. And it says the network 192.168.10.0 is divided into 4 subnets. We know that, 2 to the power of 2. And each subnet has 64 total possible IP addresses. How do we know that? 2 to the power of 6. Okay, so we only got 64 total IP addresses and -2, so 62 usable IP addresses. Okay, same here. Each subnet, they have equal number of usable IPs, and they all have network and broadcast addresses. Now, 3-bit subnetting. We borrow 3 bits from the host portion. There's 8 different possible subnets. Okay, so it says just same network. Let's see, 192.168.10.0. Yeah, same network. 192.168.10.0 is divided into 8 subnets. 32, only 32 hosts possible. Okay. This is a diagram here. Equally, equally divided into 8 different subnets. Okay. As I said before, each subnet has the equal number of usable IP addresses. Okay, last portion. Part 2. Excellent. Just wait for it to load. Now it's the 4-bit. You borrow 4 bits for the network part from host portion. Okay, so it's how many? 16. Okay, says the network 192.168.10.0 is divided into 16 subnet, which is 2 to the power of 4, because we borrowed 4 bits, and each subnet has 16 total possible IP addresses, because 2 to the power of 4, 16. Okay, how do we know that? We got 4 bits reserved for host now. These 4 are for the different networks, right? Okay, so this is the table. The total, the maximum number of bits we can borrow from the host portion is 6, because let me explain. We got, this is a class C, then we got, he says this is Y designates the borrowed bits. How many? There are 6. Corresponds to this entry over here. How many possible hosts? Two to the power of 2. It's 4, right? How many possible usable hosts? 4 minus 2 is 2, right? But what happens if we borrow 1 more bit? Okay, how many possible hosts? Just 2, right? How many usable hosts? 2 minus 2 is 0. That's why the maximum number of bits you can borrow for class C is 6. Okay, that's it. Thank you very much. Have a nice day.